Here begins Lesson 10.3, Part 2. Now, if you remember, we were trying to get or solve equations with radicals, with the variables inside the radicals. All right, so to do so, we have to isolate it. So therefore, we are now at example 4, which deals with a situation where we have a little bit more work to do. Remember, we cannot get rid of the square root until it's by itself on one side of the equation, so I must isolate it. And in doing so, I would add 10 to both sides. I would get x minus 1 inside the root still, and on the other side I would get 8. We would then square both sides, just as before, which would give us x minus 1, because the root and the square simplify. We have 64. We would then add 1 to both sides, which would give us x equals 65. And again, if you check that, 65 minus 1 is 64. Root of 64 is 8. Negative 10 plus 8 is negative 2. So a little bit more work before we can actually undo the root. All right, this one we have a negative 8 times the root. So we have to have the root by itself. So I have to do the opposite of what's occurring here, which is negative 8 times the root. So I'm going to divide by negative 8. And that will give us n plus 1 by itself, or the root of n plus 1 rather. And on the other side we have 7. So as before, to undo the root we square, and we get 49 equals n plus 1. Subtract the 1 from both sides, and we are left with 48 equals n. And that does check. All right, next one. We have to isolate it. Now this one's kind of tricky because it looks like this root covers everything, but again, the root only covers to the 2. So I need to move the 1 to the other side, which will give us 9p minus 2 inside the root equals 4. Now we can go ahead and undo the root by squaring both sides. Don't forget to do both sides. Now will give us 9p minus 2 equals 16. We then will solve this equation by proper steps, which is to solve for p by adding 2, which will give us 9p equals 18. Divide both sides by 9, and we have p equal to 2. And again, that also checks. Now, sometimes we have a unique situation, which is shown here, and that is that if both sides contain a radical, okay, they have a single radical, so a single radical on both sides of your equation. Now they're both considered isolated. They're both by themselves. There's nothing errant. There's no plus or minuses or times anything outside the roots. So the good news is we just have to square both sides. And in doing so, we end up with b plus 10 equals a negative 4 minus b. So we just have to solve for b. A couple more steps with there then. All right, so we get our like terms together. So we add b to both sides, which gives us 2b plus 10 equals a negative 4. Add 10 to both sides, subtract 10 from both sides, which gives us 2b equals negative 14. Divide by 2, and then our final answer will be b equal to negative 7. And again, if you plug that in, you'll end up getting root 3 equals root 3, and that checks as well. All right, so this ends lesson 10.3, video part 2.